As you may heard, I'm manager right now, but today's story starts 9 years before this date. Today, I'm going to speak about how we developed our product over the course of 9 years, what issue we had there, and how we did solve them. There is going to be a time for questions at the end of the presentation. Now, let's see what is actually ManageWP. Don't worry, this is not going to be a sales presentation, just a quick intro. ManageWP is a software as platform and service for web agency and web professionals that are building WordPress sites for others. It provides tools like backup, clone, client report, security scan, performance scan, automatic plugin installs, client report, and many other things. Currently, there is like more than a million websites under management on this platform, so there is some kind of scale and complexity behind this. And that's all that I'm going to tell about ManageWP. Now, let me ask you the question. How would you describe the current state of your project? Like completely ideal? Maybe something in the middle? Or something like this? You're pretending it's fine, but actually it's falling apart on every step. Now let's see what should be ideal project development environment. You maybe heard about TDD or BDD, or maybe you're going to hear about that today. Maybe you want to write tests because you don't want to have bug on production. Maybe you're dealing with money and you don't want to have mistakes there. You want to cover all edge cases, and you want to be sure that your code is actually working on the production. The next thing that you maybe want to have is code review. Why? Because you want to know that you actually wrote the good test and you are testing the right thing. You maybe want to pass the knowledge to your junior colleagues. And this is the one really easy way to do. The next thing that you maybe heard about and want to have is continuous integration and continuous deployment. Why? Well, maybe you would like to have metrics on every git commit, git push. Maybe you would like to run all these previous tests automatically. And you want to be sure that they pass to the production when everything executed. Now I'm going to ask you the question, do you have all of this? Please raise your hand. Oh, OK, nice. The next thing that you maybe want to have is scalable infrastructure. Why scalable? Because you want to be able to scale up when you have a lot of workload to do or when you are covered by some popular internet magazine. And you want to scale down when there is no need for that, so you want to save money. Maybe you would like to have that infrastructure on cloud. Why on cloud? Well, there is a couple of reasons. Maybe you don't want to deal with physical servers, ordering, provisioning of that. And also on cloud, you have a lot of services that are already there for you, so you can just use them. So that's one of the reasons. Then you maybe would like to have complete automation of your infrastructure and self-healing infrastructure. Maybe you would like to have serverless architecture because you don't want to deal with servers. And you want to have this because, for example, if one instance goes to spike or crash for any reason, you want to have that automatically replaced. And you want to have some kind of peace. Then you would like to have complete monitoring solution in order to support your automation and also to gain you insight in your data and your user behavior and your infrastructure. Maybe you would like to have just only one alert in 2 a.m. in the morning when there is real need for that and not like 5 false alerts during the night. So like there is no any kind of alerting in that case. Maybe you have heard about agile methodology and you maybe would like to use something like Scrum, Kanban. The reason for that is maybe because you would like to have daily sync meetings to see if there is any kind of blocker. You would like to have some reasonable planning like in the future, like typically in sprints 2 weeks, and that's called sprint. because you want to know what you're going to do and what you're going to do the next. And maybe you would like to have retros because there may be some issue that you haven't already covered with your process, and you would like to address that and to retro that. Now, let me ask you a question again. Do you have all of this? Please raise your hand. A couple. OK. Few hands, but less than previous question. And my key takeaway is that actually many projects, especially startup project, does not start like this. There is no ideal world. So you will usually start without many of these infrastructural things or without any process. You will build something like proof of concept and try to test that with real users. Now let's see how we started, actually. It was 2010. I wasn't working in company at that moment. And there was a group of few people that was building sites for other people. After some time, they had issue actually to maintain all that site because they had to do regular backup, regular maintenance, like, I don't know, plugin updates and things like that. So they have searched market for any solution. There was none. So they had idea. And in today's world, when it's easy to outsource your solution to someone else, they did that, and after a couple of months, they got the solution. What do you think it was the infrastructure? It was one server. One server that was web server, application server, database server, storage server, everything on that. There was no any kind of cloud or any kind of serverless architecture. The code base was actually just two WordPress plugins. One plugin was like client plugin that was installed on client website, and other was like dashboard solution that will gather all the information and statistic. Why this was built like WordPress plugin? Well, it was logically because it was WordPress solution. Do you think there was any kind of test? Yep, there was no any test. No any unit test. Do you think there was any kind of functional test? Yes? No? Yes? Yeah, there was functional tests. Users were performing them, actually. There was any kind of Selenium or any kind of that kind of browser test. This was outsourced to user. You see, you can save money like this. Now, let's see what was the deployment procedure. It was one really simple, git pull. In PHP world, Python world, I guess, sometimes even in front-end world, it's really easy to just do git pull, and if there is any kind of build, you just run few comments or without any command running. Have you performed something like this in the past? Please raise hand. Yeah? Don't be ashamed. Now let's see what was about object-oriented programming. There was actually one class with 10,000 lines of code, and that class was inherited by every other class in the project. There was around, I think, 1,800 switch case statements in this class. So someone was really learning programming without actually knowing any pattern. We had to disable code coloring, code linting, and any other code feature when we tried to open this class because it was hard to maintain because code editor would freeze or crash. So this was fun to maintain. Now let's see about the business side of this product. After a couple of months, there was a few hundred users using this product. The revenue per month was about 5 figures, probably more than you're earning today. After a couple of months, there was a 3-clone product. One product actually took our client plugin because it was public and just renamed it, rebranded it, and built the master solution around that. So this guy actually created the market. And my learning from this and takeaway from you is that you don't need to have really cool backend in order to gain traction from your users. Cool backend is going to help you to maintain that, but first you need to have solid user base in order to have any product. Now let's see what was the evolution of this product. Many features were added, many bugs were fixed, and the solution scaled from 1 server to 2 servers. Again, this was all in one server with web application, web server, storage, MySQL. Now just there was second server that was replica of that server. I have joined company in 2013 and started working on this product at around 2014. The first issue with this was that there was poor monitoring, actually almost no kind of monitoring. One day I logged to the server and started poking around to see what is the configuration, because you can guess there was no any kind of provisioning software used in this moment. I have noticed that MySQL replication is actually broken for the month. I was shocked, but fixed that and continued my day. 1 week later, I was giving the presentation on WordPress meetup, actually, and my phone started buzzing in my pocket. I just ignored that because I was giving presentation, but I have noticed worried face of my colleagues in the crowd. We were down. What happened? Failed RAID controller. We rerouted traffic from primary server to the secondary server, and that took some time because in this moment this was just like DNS switch. We contacted the data center, and the technician changed the failed controller. But because there was no the same controller, they put the replacement controller, and they did wiped out our disk hard drives completely without asking us or without telling us. What that could mean for us? 0 revenue. Just my pure luck 1 week before that saved us from that, and actually this is the reason why I'm still here today and there is the product. From this point on, we actually have automated monitoring system on our application, and today we actually have complete backup check procedure that is actually checking if our application is possible to restore. Now let me ask you the question. Do you have any kind of monitoring system on your application, on your backup? Please raise your hand. Yeah? For the rest of you, probably it's a good idea to create it after this day. Now let's see what was the second issue, user backup. You remember that one functionality was backup. And we relied on WordPress cron in order to have this functionality. There is one specific detail about this. WordPress cron is not the real cron, so you need to have traffic in order for this cron to work. Many users didn't have regular traffic, or they didn't have any traffic for some time, so their backup will be delayed, or even worse, there will be no any backup. Pretty bad for one kind of software that we are building. At that point, we had around 2,100 websites under management. So we decided to create fake traffic for these websites. Easy, right? Well, it was easy for us. We created just one Node.js application because it was good with I/O operation, and that solves problem for our user. But that created another issue for us. There was ping back notification at the end of the backup. So when the backup is completed, they will just phone back the master to tell, like, OK, I have completed this backup. Here are the information. And we will use this information to send email notification or to aggregate that data. The problem was that, you remember, we were on one physical server. We were not able to scale. And with this volume of ping back notification, we were actually DDoSed by our own users. The solution for this was actually to just disable this path on the server, and we were left without some data because of this. But this was the only way for us to survive. So not the good thing. My takeaway from this is that you really need to pay attention to your data. Create regular backup, put monitoring, and even in today's world, when encryption is really important with GDPR, and if you're dealing with sensitive data, please encrypt your data. Now, let's see how we went further in the future. We were sick with all of these bugs, so we decided to rewrite and refactor. And as developers, we usually tend to ask for this kind of thing. And we finally got approval in 2015. We chose our technological stack, and the first thing that we chose was AWS as cloud. Why cloud? Because we could not scale in the previous solution. We had some experience, like for personal project, but we didn't have any large-scale experience, so there was huge learning opportunity here. Then we chose the backend framework, and that was Symfony. That's PHP framework, actually. And all team members knew this really good, so this went well. Then the next thing that we chose was the storage. MySQL was obvious, but we chose MongoDB. Why MongoDB? Well, it was a cool buzzword in that moment, and we had to have some kind of NoSQL storage. So this also created a huge learning curve for us and a lot of problems. The next thing that we chose was the front-end framework, and that was AngularJS. At least every team member did some kind of application, like to-do application, notes application, but no one did actually some large-scale one-page application. So again, this was our learning opportunity. Then we had our first continuous integration pipeline. We were happy about that, but the owner was not happy. Why we are paying additional money for this environment? Why deploy is taking so long now? We need to have like 10 seconds rollback. Why 10 seconds? Well, you remember that we had like Git pull as deployment solution in previous, so Git revert is also one really quick. So we somehow managed to stay with this pipeline, and we were happy, but we had a lot of issues to solve also with that. Our infrastructure at the first looked like this. We had one network load balancer that was handling user requests. Then there was two auto-scaling groups behind. One was designed for web server, another for backup workers application that was performing user backup. At this moment, everything from this picture was manually provisioned again, because we didn't have time to write some kind of automation for this. And there was few issues with this, but we somehow overcome that. We used database in this moment like primary, secondary for MySQL and MongoDB at this moment, and we used S3 for storing user file. The deployment now was that we actually would deploy the code to the gold instance, and the gold instance is actually instance without any traffic. We will then do the snapshot of that, and from that snapshot, we will create a new auto-scaling group. That auto-scaling group will be registered to load balancer, and the previous auto-scaling group will be destroyed. The deployment process at this moment took us around 1 hour. So everybody were complaining about this. And, well, at least we did this with some kind of automation. In that case, we were using Ansible. At this moment, the only scaling metric for us was CPU usage. Until one day, one instance crashed because of memory usage. So someone had the idea, let's add another metric to our scaling group. And we did that. But that created issue number one. We were completely stuck. Why? Well, when you have like high CPU usage and low memory usage, CPU usage is going to scale you up, and memory usage is going to scale you down. But the moment when we deployed this, we were stuck with the number of instances that we had at that moment, so we were not scaling anymore. So we learned how to scale with two metrics, created a third metric, and do some calculation based on these two previous metrics. Then the next issue was that long executing actions like performance scan that I mentioned you were executed from web server context. Why we did it like that? Well, we were in a hurry to build the features, and we didn't have time to put in the first some queuing system and offload to the backend. This created a few issues, like some server will have less luck, and they will pile up with all long executing action, and they will be crashed. The other issue was for our user. because the only way how you could get the progress was that it's just from the open connection from one browser tab. The users were actually opening multiple tabs, so they would have like stale data on their dashboard, and it would create weird bugs for them. So this was not fun. Finally, we decided to actually put queuing system in the backend, and we tasked our junior colleague to actually do that. We gave him software like RabbitMQ, ActiveMQ, and give him requirements to test if that's going to be satisfied. He tested that, but he concluded that actually none of the software is able to satisfy us. So he decided to write a queuing system using only just Redis with a few lists and few sets. I must say that this performed really bad, and it was a huge scaling issue also. But it was just slipped to the production. You remember, at this point, we didn't have any code review. So this is the way how this went into the production. Later, we actually replaced this queuing system with real RabbitMQ system that we use even today, but not with the problems. Now our infrastructure looked like this. Still, we had load balancer for our incoming HTTP traffic, and behind that, there was a web server auto-scaling group. This web server will now just pass the message to the queuing system, and the appropriate application will pick up that from the queue system. There was auto-scaling groups per function, like for security scan, for performance scan, for backup, so something like microservice architecture. The result will be stored to the database, and then the front end will just pull that information, and every browser tab will actually have the correct state. At this moment, we actually switched from MongoDB primary, secondary to actually real cluster. Now let's see what other issue we had. You remember MongoDB, the cool buzzword? Well, when we started, there was, I think, MongoDB 2.02. So there was two engines. One was stable, other was like experimental beta engine. So we opted in for stable engine. But that engine actually required a lot of RAM memory, operating memory, and a lot of disk storage. And there was a lot of swap between operating memory and storage. So this also required a lot of I/O operation on disk. We had to scale a lot in order to be able to have decent performance on this engine. So this was our learning opportunity. Later, we switched to wired-target engine that was using compression. And that engine actually now is default engine in MongoDB. But we had to have like 6-hour downtime in order to switch this engine. And we could do that because we were in beta, but in real production, this is going to be really bad. The next issue that we had with MongoDB is actually schema. You may ask me how schema, because this is no schema document, it's document-based. Well, you at least need to store your data somehow, and this is at least some loosely defined schema. We designed schema by business requirement when we started building this application. So we were using like one flat document with a lot of embedded documents inside them. This created an issue for us because we didn't know that you cannot query embedded documents and to use the index, cover the index, without actually going to the disk and fetching that document. So our performance was really bad. Then the second issue with this schema was that because there is some kind of limitation on the document size, we could do backup for our users only like for 2 years. So I went to owner in that moment and prepared all my arguments, and I got no. Someone else is going to take care of this. 2 years is enough time. So the only solution that we could do at that moment is actually just copying the data from latest document to the flat structure, but because that was important for us. And that solved our performance issue. But we now have duplicated data. And even today, we use this schema because it's really hard to change schema when you have terabytes of data here. So choose your schema wisely. The next issue was backup retention for our user. We were storing user file by hash value, and one day we got a ticket that one user is actually missing some file. During the debugging session, we have noticed that this particular user had copies of the same file on multiple locations on their site. So when the retention kicked on and deleted one file that was expired, it also deleted the one that was still live. Someone did not pay attention to this problem, so there was inconsistency with this backup. We started further debugging and researching, and we have noticed that actually 80% of our user backup are inconsistent. Pretty bad. How do you think we solved that? We just deleted user backup. They were not happy about this, but we sent a message why we are doing actually, and that this is for their good actually, because we cannot guarantee consistency, and that we actually fix this problem. So you see, we had a lot of problems and issues during this period. So my takeaway for you is this, that you really need to be honest with your users, because things are going to go wrong. And when things go wrong, don't try to cover up them. Be honest with them. Tell them what happened, how you're going to solve that, and how you're going to prevent that from happening again in the future. This way, you're going to build trust with them and loyalty. So, again, some time passed again, and we were ready to do launch of our application to all audience. We set a date and came that day to the work. But there was one minor issue. There was like last-minute request changes, and that changes actually took us more than 30 hours without sleep. There was changes like UI changes, functionality changes, even some core functionality changes. So the date passed, and it was the next date. We were finally ready to launch our application. And we started our migration script from legacy to the new system, and we were happy about that. We went to celebrate that, and about 1 hour after we started celebrating, we went back to check the progress of our script and to see our statistic. We were at 0 revenue again. Like, seriously? Again? We are still experiencing this? What happened? Well, migration script actually canceled all user subscription because there was a bug there. Did we learn something from previous experience with near 0 revenue? Yes, we did. We actually had prepared backup in case of this scenario or any kind bad scenario. So we restored our database, started merging our data, and I must say that this was not the fun thing to do after 30 hours without sleep. The whole deployed and pushed to the production was around 35 hours. I can remember that after this deploy, actually this was my longest sleep, around 16 hours, and I usually sleep around 6 hours. And all team members at that point will remember this date. During this process, actually, and with all of this problem, we were actually creating value to our users, and we were adding a feature, and we were different from competition. This was recognized actually by our users, and we gained more users even with solve this problem. This was also recognized by other companies, so we started talks about acquisition. Now, finally, it was September of 2016, and we joined GoDaddy family. You may ask me what's changed from this acquisition. Do we still have issues? Yes, they happen from time to time. Not like this, but they do happen. The first thing that's it's more important is that we aren't a startup anymore. That means that we are not anymore fighting for the market because we have more opportunity to expand right now, and we are creating our decision with more information and data in the mind. We have also improved our process a lot. That means now we know how some feature is going to build, why, for whom, how that feature is going from product owner to the design team, and how that is handed off to the developers. Then from developers to marketing, and then to the release. We have also introduced code review process. And now it's much easier for our junior colleagues actually to find out about our system, because it's quite a large system now. And for our senior colleagues, it's really good because you cannot know every part of the system that well. So someone is going to review that and tell you if you're doing that really good, or you have some kind of bug or anything that you don't know about that. Then the next thing that we did is actually we completely automated our infrastructure. We have added Terraform in this process actually to provision our infrastructure. And we now write our infrastructure as code. That code goes to code review process, so everything is checked now. There is go through the same process for everything. And it's now much easier for us. Also, we have completely automated our, not just the deployment, but also spinning off new auto-scaling group. Now that's just one button push in our Jenkins environment with few parameters. It's much easier for us. Also, we have improved our monitoring. Now we have more data about our application, like from system side, like resource usage, but also from application part of the site, and from our user side. Now we know how our application is used, what is the most frequent tool or button used, for example. So this also creates us a good data in order to make for us decision. And also for our infrastructure, it's really good because we don't need to worry much about things. So it's completely automated and it's self-healing. We have also added a lot of tests now, like real unit tests and real Selenium tests that are opening Chrome and doing testing. And we are not anymore outsourcing that to our users. So we have added everything from the start of the project, and now I can raise my hand that we have ideal project environment. Why did us took so long to do this? Well, because we were first fighting for the market. And if you do set up ideal project without any user, that project is going just to be a dead project, because no one is going to use that. That is also important for open source project, because you are not going to maintain any project if no one is using that. So you first need to build your user base and then improve your backend. And that we were doing. We all knew about tests, continuous integration, but we didn't just have time to implement that because we were fighting for our user. That's the most important thing. Now let me quickly run through all of important stuff. Like I mentioned, there is no ideal world. Most of the project will not start like ideal project. They will start like quick requirement from business, like proof of the concept, or if you're in the startup industry, you're just going to build a project without any tests, without any continuous integration, without anything, because it's important to gain your user. Second takeaway is actually that you need to have user. You need to have your user traction. You need to have your minimum viable product and to get the feedback from that users. Then after that, you can build the cool backend. Cool backend is going just to help you to maintain that and to save you time in the future and probably save you from bugs. But that's not going to build your user, well, at least not in many cases, maybe if you're just some kind of technological startup or some niche. Then please make your data completely safe. Do encryption, create regular backup, create monitoring on your application, check if you're able to actually restore that. Even if you're using serverless technologies like AWS, RTS, check that snapshots are really able to restore and that you have accurate data. Then when things go wrong, and they are going to go wrong, be really honest with your users. Tell them what happened, tell them how you are going to fix that, and how you are going to prevent that from happening again. You are going to build trust and loyalty with them, and they are going to stick to you. During this process of building your product, create innovation. Create something different from the rest of the competition. Add value to the market, because this is going to bring you the customers and maybe acquisition if you're a startup. And the last, but most important, remember, there is no ideal project, without actually any user. That project is just going to be that project. And that's are the key learnings that we took from 9 years of development of our product, and that I wanted to pass to you. Thank you.